Hi everyone, in today's video we are going to be going through some exponent laws and going through some subsequent examples to go along with them. So let's get started. The first exponent law we are going to be looking at is the product law. This occurs when we are multiplying two or more values with the same base raised to an exponent. So here we have a to the power of m times a to the power of n, and what we will do in this case is we will add the exponents while keeping the same base. So we have a to the power of m plus n. An example of this would be, say we have 2 to the power of 3 times 2 to the power of 2. We're going to add these exponents, so we have 2 to the power of 3 plus 2, giving us 2 to the power of 5. You can evaluate this with your calculator and you will see you'll get the same result. So to summarize, this case for the product law, we want to add the exponents. Okay, the second law we're going to be looking at is the quotient law. Quotient law occurs when we have a value raised to an exponent m divided by another value raised to an exponent n that have the same base, and we're dividing the value raised to the power of m by n. And what we want to do here is we're going to subtract the exponents, so we're subtracting the exponent value in the denominator from the value in the numerator. So basically we have a to the power of m minus n. If we were to have an example of this, we could say that we have 3 to the power of 5. Oops, that doesn't really look like a 5, sorry. 3 to the power of 5 divided by 3 to the power of 3. This is equivalent to 3 to the power of 5 minus 3, which is equal to 3 to the power of 2, which we can evaluate to be 9. This can also be expressed as 3 to the 5 divided by 3 to the 3. We would evaluate this in the same process to get 9, which just can be expressed in another way. Also, it should be noted that these examples are just like arbitrary examples that I'm choosing. This can be represented by a lot of other numbers in other instances. This is just, I'm choosing these numbers at random. Okay, so in summary, in this case, we are going to subtract the exponents. Okay, moving on, we are going to be looking at law number 3, which is the power of a power law. Basically, in this case, we have some base a to the exponent exponent m, and then that is itself raised to an exponent n. In this case, we are just going to multiply the exponents, and then that is put to the power of base a. So an example of this would look like if we had something like 4 to the power of 2 then to the power of 3. That could be expressed as 4 to the power of 6. Or if we have something like x to the power of 5 and to the power of 4, that would be expressed as x to the power of 20. So in summary, here we want to multiply the exponents. Okay. So moving on, we are going to talk about the next law, which is the power of a product law. So this occurs when we have two different base values a and b, so these two values that are being multiplied together, and these are both raised to some exponent m. So what we want to do here is we want to multiply each number to like the power of m. So we're going to express each number to the power of m and then multiply those together. So we should get something like a to the power of m times b to the power of m. So an example of this would look like 2 times 3 to the power of 4. This is equivalent to saying 2 to the power of 4 times 3 to the power of 4. I mean, you could obviously just simplify this as 6. 2 times 3 is 6, and then express that to the power of 4, but this law becomes a lot more useful when you don't have such simple numbers like 2 times 3, or if you have like a variable. For instance, I could have something like 2x times y to the power of 3, and then I would have to express this as 2 to the power of 3, x to the power of 3, and y to the power of 3, or 8x to the 3, y to the 3. So that's how the power of product law works. So basically we're somewhat like distributing this value of m, this exponent value m, and we're raising each value that is being multiplied to each other to the power of m. Okay, so I'm just gonna say like distribute. Oops, it's not red. Distribute the exponent. Okay, moving on to our fifth law. This is the power of a quotient law. So in this law, we have a fraction of a over b. Both are being raised to the power of m. This fraction is being raised to the power of m. What we want to do here is we want to divide a to the power, so we want to take a to the power of m and divide it by b to the power of m. Okay, so an example of this would look like something like if we had 2 over 3 to the power of 4, that would look like 2 to the power of 4 divided by 3 to the power of 4, which would be 16 over 81. Or if we had something like 2x divided by y to the power of 2, this would look like 2 to the power of 2 times x to the power of 2 divided by y to the power of 2, or 4x squared divided by y squared. Remember here, as in the numerator, we multiply both we apply our previous law, which is the power of a power law, and the power of product law to simplify the numerator into what we did. Okay, so what we need to remember here is we want to express the numerator. I'm just going to say num for short. I'll say that for short. To the power of m. Okay. Now moving on to our sixth law, which is the zero exponent law. Personally, I think this one is the easiest. Basically, the zero exponent law says that anything to the power of 0 is 1. So, oh, it's in red again. Sorry, it should be in black. Anything to the power of 0 is 1. So, have base a to the power of 0 is 1. If I had some value in an example here, like 2 to the power of 0, that's 1. 4 to the power of 0, it's 1. X to the power of 0 would also be 1. I think you get the point. You can punch this into your calculator if you don't believe me. There are explanations as to why this occurs. It might not seem exactly intuitive from first glance. I'll link a video below of a fellow YouTuber explaining this concept. I think it's actually really well explained, so you can feel free to check that out. But yeah, so this is the zero exponent law. So in summary, anything to the power of 0 is 1. Okay, moving on to our last law here. It is the negative exponent law. And basically in the negative exponent law, we have some base a raised to the power of a negative value, so in this case negative m. And this would basically be expressed as 1 over a to the power of m. So basically taking the reciprocal of the value if it was a positive exponent. So an example of this would be, say we have something like 5 to the power of negative 2. This could be expressed as 1 over 5 to the power of 2, which could be then expressed as 1 over 25. We can also have another example that's a little more complex, like 2 over 3 to the power of negative 3, which would be expressed as 1 over 2 divided by 3 to the power of 3. And then we would evaluate 2 to the power of 3 using the power of a product law, which we just learned above. So we would get 1 over 2 to the 3 divided by 3 to the 3. And then we would take the reciprocal of that, so it would be 3 to the 3 divided by 2 to the 3. And then we would get 27 divided by 8 if we simplified. Again, you can punch this into your calculator and you will see that you get the same thing. Okay, so that is pretty much it for this video. I hope that this was helpful in giving you a brief introduction to exponent laws. I know that this video was a lot of content in a short amount of time, so if you are still confused, feel free to drop your questions down below. I'll be happy to help. And yeah, that's it for this video. Thanks for watching. Bye.